Good morning to all. In last lecture, I told about lossless decomposition. There are two conditions for good lossless decomposition, or there are two features of good decomposition. One is lossless decomposition and another one is preservation of dependencies or dependency preservation. Okay. And now you all are going to learn Aho-Berry-Ullmann algorithm to check whether decomposition of R is lossless join or not. Is PPT visible to you all? Hello.
Yes, sir.
This is the Aho-Berry-Ullmann algorithm. This algorithm will determine whether a decomposition R1, R2, Rn of R is lossless joint decomposition or not. Here we decompose R into n subschema. We decompose R into n subschema R1, R2 and Rn. And suppose R has m attributes A1, A2, Am. So in this algorithm, we will draw a matrix of n cross m. N represents the number of subschemas and m represents the degree of R or number of attributes. So m number of attributes, okay, and n number of sub relations, and here number of sub relations is n and number of attributes is m. So we will draw a matrix, two-dimensional matrix of n cross m. Matrix of n cross m. So first step in this algorithm, we will draw two-dimensional matrix, and n rows is equal to number of subrelations and column equal to number of attributes in R. Then in second step, we will initialize the matrix as follows. So here we will use nested loop. For I equal to 1 to n, and then inner loop for j equal to m. If aj belongs to Ri, then mij will initialized with small aj, else mij is initialized with bij. Okay, we will check each subrelation R1, R2, Rn, and if any attributes aj belongs to Ri, then mij, this cell is initialized with aj, else cell is initialized with bj. aj is called distinguishing element. aj is distinguishing elements and bij is non-distinguishing elements. Okay, so first step is we will draw two-dimensional matrix, and second step we will initialize matrix with aj and Bij. If any attributes of Ri belongs to jth column, then we will store Mij cell with Aj, else we will store Mij cell with Bij. Did you get it? Second step. Hello.
Yes, sir.
Then third step. A is distinguishing symbols and B is non-distinguishing symbols. In third step, for each functional dependency alpha determines beta holding on R, we will identifying pair of rows where if alpha is matching for that pair, therefore beta values are to match by replacing the B symbols by A symbols. If left hand side will match, then we will match right hand side also, because as you all know definition of functional dependencies, if alpha determines beta for any tuple pair T1 T2, if they are agree on their alpha values, they must be agree on their beta values. So by the definition of functional dependencies, we will replace B symbols with A symbols, and we will repeat step 3 till changes are possible. If no changes, then we will stop the process. Again, in step 4, if any of the rows contains all A symbols, then it is lossless decomposition, else it is lossy decompositions. And if we find any row which contain all the A symbol, then we immediately stop the process and your decomposition is lossless. And if we are unable to get any row which contains all the A symbols, then that is lossy decompositions. Did you get the algorithm? Hello, Mileni.
Yes, sir.
There are 4 steps. First step, we draw a two-dimensional matrix. In second step, we initialize matrix with Aij and Aj and Bij. And in third step, for each FD, we will check if any tuple pair match alpha values, then we will match beta values by replacing B values with A values. If any of the rows contain all the A's, then we will say that it is lossless decomposition, otherwise it is lossy decomposition. Okay. Now I am going to solve a question, then you will understand this algorithm in a better way. Okay. There is a relation R and attributes are X, Y, W, Z, P, Q, and we decompose this relation into R1, and in R1 we have Z, P, Q, and in R2 we have X, Y, W, P, Q, and set of functional dependencies are X, Y determines W, then X, W determines P, and then PQ determines Z, and XY determine Q. Now we will check whether this decomposition is lossless joint decomposition or not. So with the help of Aho-Berry-Ullmann algorithm, we will do this. So what is the first step in this algorithm? Please let me know. What is the first step? Mileni,
Yes, sir.
what is first step? We will draw two-dimensional matrix.
X.
Number of the rows, number of the subrelations. So here number of the subrelations is 2 and number of the attributes 1, 2, 3, 4, 5, 6. So we will draw 2 cross 6 matrix. Did you get it? Hello.
Yes.
So according to step 1, we will draw algorithm. We will draw matrix, two-dimensional matrix in which number of row is 2 and number of column is 6. This is X, Y, W, Z, P, Q, and number of the row is 2, R1, R2. So I think first step is clear. Hello. Himanshu,
Yes, sir.
first step is clear.
Yes, sir.
Now tell me about second step. We will initialize each cell with either distinguishing symbols or with non-distinguishing symbols B. For that we will check if AJ belongs to RI, then AIJ, MIJ is initialized with AJ, else MIJ is initialized with BIJ. So here see Z belongs to R1 and suppose this is column 1, this is 2, this is 3, this is 4, 5 and 6. Then this Z belongs to column number 4. So this cell is initialized with A4. So this cell Mij is initialized with Aj. Did you get it? Hello.
Yes, sir.
Again P belongs to R1 and P represents the column number 4. Then this cell is initialized with A5. Q belongs to R1, then this cell is initialized with A6 and rest of the cell is initialized with B11, B12 and B13. Did you get it?
Yes, sir.
Yes.
Now initialize second row. Millennium. Initialize second row. Capital X belongs to R2 and X represents the column number 1. Then this cell is initialized with A1 and this is initialized with A2
Two.
and this is initialized with
A3.
A3 and this is A4. Hello.
सर Z तो उसमें नहीं है ना R2 में.
Okay. Very good. Now you are understanding the algorithm. This cell P is in R2. Z is not in R2. P belongs to R2. So this cell is initialized with A5 and this cell is
A5.
initialized with A6. And what about this cell? What about
B4.
B?
B24.
B24. Good. So I think that you all understood the step number 2. First step, we will draw two-dimensional matrix of n cross m, n number of the subrelations and m number of the attributes in R. And second, if Aj belongs to Ri, then Mij is initialized with Aj, else Mij is initialized with Bij and I represents the row and J represents the column. Did you get it? Hello.
Yes.
Now what about step number 3? What about step number 3? Step number 3 is any functional dependency if exists on R, alpha determines beta. So for any two rows, if that is agree on alpha value, that must be agree on their beta value. If on right hand side there is distinguishing element and in another row there is non-distinguished element and non-distinguishing element in B, then we will replace B by A symbols and we will do this process until changes occurs. And if in the last we get any of the rows contain all the A's, then your decomposition is lossless, otherwise lossy. Did you get it? Hello. Mileni. Now see this functional dependency. X, Y is alpha and W is beta. So we will check for this functional dependencies. X, Y. X, Y. And then W. But no row. Okay, we found here for which alpha is equal. So this FD is not useful for us. Then we will check XW determines P. Here XW determines P and no row. Okay, for that alpha is equal, then this is not useful. Then we will check this FD. PQ determines Z. PQ determines Z. This is PQ and PQ determines Z. Now see here, left hand side PQ is equal to, then we will replace this beta values with A4. Did you get it, Himanshu?
Yes,
For
sir.
these two rows, left hand side are equal, then we will replace B values with A values. So for this FD here we have A4, then B24 is replaced by A4. Now this row contains all A's, so this decomposition is lossless decomposition. It is lossless decomposition. हेलो
सर इसमें अगर जैसे A5 A6 दोनों सेम है, अगर B1 B11 B12 ऐसी सेम होता तो मतलब पॉसिबल है वो?
क्या आप क्या कह रहे हो बताओ?
एक ही जगह सेम हो।
एक ही जगह कहाँ पे, किस सेल की बात कर रहे हो आप?
नहीं 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 हो सकता। नहीं सर,
किस
आ
सेल
गया
है? आ
वो
गया?
मैं कि एक ही जगह अगर बी वाले सिंबल होंगे लेकिन सेम नहीं हो सकते वो।
अगर लेफ्ट हैंड साइड का सिंबल सेम है तभी तो आप राइट हैंड साइड के सिंबल को सेम करोगे, और राइट हैंड साइड पे अगर कहीं बी है और दूसरी जगह ए है तो बी विल रिप्लेस बाई ए। डिड यू गेट इट? हेलो।
यस सर।
और ये हम तब तक करेंगे फॉर ईच एफडी जब तक चेंजेस होते रहेंगे, और ड्यूरिंग द प्रोसेस अगर किसी भी रो में ऑल एज मिल गया तो इसका मतलब इट इज लॉसलेस डिकम्पोजिशन, अदरवाइज इट इज लॉसी डिकम्पोजिशन। और अगर आपको ऑल एज मिल गया देन यू कैन स्टॉप द प्रोसेस, क्योंकि नाउ देयर इज नो नीड टू चेक। ओके, मीन्स नाउ ऑल द एट्रीब्यूट्स आर determined, functionally determined. Did you get it? Hello.
यस सर।
Now solve second question. R is A1, A2, A3, A4, A5. We decompose R into R1, and in R1 we group A1, A3, A4 attributes. In R2 we group A1, A3, A4. Here we group A1, A2. Sorry. In R1 we group A1, A2, A3, A5, and in R2 A1, A3, A4, and in R3 we group A4, A5, and functional dependency FD1 is A1 determines A3, A5, functional dependency 2 A5 determines A1, A4, and functional dependency 3 is A3, A4 determines A2. This is A5. And this is A3, A4 determines A2. Now tell me whether this decomposition is lossless or lossy. Here we will draw 3 cross 5 matrix. Did you get it? Hello.
Yes, sir.
Please solve this question. First step, there are 5 columns and 3 rows. This represent R1, R2, R3, and then A1, A2, A3, A4 and A5. This is the matrix of 3 cross 5. Okay. Then A1, A2, A3, A5 belongs to R1. Then here we will write A1, A2, A3, A5. And here we will write B1, 4. Then in second row, here A1, in this case A3, in this case A4, and this is initialized with B22, and this is B25. And for this is initialized with A4, this is initialized with A5, and here B31, B32 and B33. Now for each FD set we find out the 2 rows, and if left hand side is equal, then we will replace right hand side by a symbol. Okay, and if you get any of the rows contain all the A's, then it is lossless decomposition, otherwise it is lossy decomposition. Now apply step 3 for each FD. Did you get it? Himanshu?
Yes, sir.
Yes, sir.
So now tell me whether it is lossless or lossy. Here we will check A1 determines A3 and A5. For these 2 rows, this is also A1 and this is A3, and here this is A5, so this will be replaced by A5. Did you get it? Hello?
Yes, sir.
Yes, sir.
Please solve this. I would like to request you all, please attend the class with notebook and pen. Now check for this FD and then for this FD. And any of the rows contain all the A's, it means that it is lossless decomposition, otherwise lossy. Now for this, here A5,
314 placed with
A5, A1 and A4. Here A1 and A4. A5 determines
same.
A1 and A4, and here A5 determines A1 and A4. Then here we will replace B14 by A4.
Oh,
Did you get it?
yes, sir.
Now first row contains all the A's symbol, so it is lossless decomposition.
सर B31 को भी तो A1 से रिप्लेस करेंगे.
हाँ, वो अलग चीज है। जब आपको एक मिल गया तो वहीं स्टॉप कर सकते हो, हमारा काम तो हो गया ना भाई।
यस
एल्गोरिथम
सर।
को आप कब टर्मिनेट कर सकते हो? या तो चेंजेस अगर हो तब तक कर सकते हो, लेकिन अगर ड्यूरिंग द प्रोसेस किसी भी रो में ऑल एज मिल गया तो आप क्या करोगे? इमीडिएटली स्टॉप कर दोगे। डिड यू गेट इट?
यस सर।
देयर इज नो नीड टू check for other FDs. Now solve this question. This is home assignment, and in next lecture I will ask about answer. Here R equal to A, B, C, D, E, and then we decompose this into R1 A comma D, R2 A comma B, R3 B comma E, then R4 C comma D comma E, and R5 A comma E. So R consists of 5 attributes, and then R1 consists of A and D, R2 consists of A, B, R3 consists of B comma E, R4 consists of C, D, E, and R5 consists of A comma E. Please note it down. Now functional dependency FD1 equal to A determines C, FD2 B determines C, FD3 C determines D, and FD4 D comma E determines C, and FD5 C comma E determines A. So let me know by applying
5
step
cross
what? 5 cross?
5.
There are 5 attributes and 5 sub-relations. So we will draw 5 cross 5 matrix. Then we initialize the matrix, and with respect to all the FD, we will replace B symbol with A symbol. And if any of the rows contain all A symbol, then it is lossless decomposition. Please do it. Still 4 minutes is left. Please do and tell me the answer whether it is lossless decomposition or lossy decomposition. Here we will draw 5 cross 5 matrix. Five rows and then 5 column. A, B, C, D, E, and R1, R2, R3, R4, and R5. AD, this is A1, at D,
If
A4. Then for R2, A1,
A2.
A2, and rest of the cell is initialized with B23, BT24, and B25. And for R3,
A2, A5.
A2 and A5, and this is B31, B33, B34. Then for R4, CDE,
A4, A5.
A3, A4, A5, and this is B41,
And before 2.
B4, and then AE, this is
A1, A5.
A1, and this is A5, and rest of the cell is initialized with
2, B5,
52, 53, and
5, 4.
4. Now for each FD, we will check. If we find any two rows where alpha side is equal, then we will replace B symbol with A symbol on the right hand side. Or if two rows are agree on their left hand side, they must be agree on their right hand side.
Right.
And this is the definition of functional dependency. That's why we are replacing Bij with Aj symbol. Did you get it?
Yes, sir.
Then replace the things and tell me whether this decomposition is lossless or lossy.
सर सर इसमें जैसे A gives C है तो A की 3 वैल्यूज रो में सेम है A1 वाली तो C की B वाली वैल्यूज को हम A से रिप्लेस कर देंगे
कितनी भी 3 हो 4 हो फॉर ईच टपल पेयर ना.
ओके सर
If we get 3, 4 or more than 5 tuple pair, then we will do the same process. ठीक है, और ये कब तक करते रहेंगे जब तक चेंजेस हो रहे हैं मैट्रिक्स में. Did you get it?
यस सर
Sometimes suppose we apply FD number 3 and then after that FD1 is useful for replacing. Then we will do this process every time in the loop until changes occur. Did you get it?
Yes, sir.
If no changes, then we will stop the process, or if we get any row contains all the A symbol, then we will stop the process, and this decomposition is lossless decomposition. And if we will not get any rows which contain all the A's, then it is lossy decomposition. Did you get it?
Yes, sir.
So in next lecture, okay, I will ask you about this decomposition, whether it is lossless or not. And second thing is whether dependencies are preserved or not. Okay. So this is very important algorithm. Now time is over. In next lecture I will explain it further. Okay. Thank you.
Thank you, sir.